Good morning, students. I am Dr.R.Suganya, Assistant Professor, Department of Computer Science with Cybersecurity. Today we are going to see about the case study of intrusion detection system. Definition: intrusion, a set of actions which is aimed to compromise the security goals, namely integrity, confidentiality, or availability of a computing or networking resource. Intrusion detection is the process of identifying and responding to intrusion activities. Intrusion prevention is extension of ID with exercises of access control to protect the computers from exploitation. Elements of intrusion detection. Primary assumptions. System activities are observable. Normal and intrusive activities have distinct evidence. Components of intrusion detection systems. From an algorithmic perspective, there are features which captures intrusion evidences. Models piece evidences together. From a system architecture perspective, various components audit data processor, knowledge base, decision engine, alarm generation and response. Components of intrusion detection systems. We have the audit records. The audit records will be pre-processed with the activity data called as detection engine. So detection models will be available and it will be detected by detection engines, and the alarms will be given by decision engine, which is being stored in the decision table, and the action report will be taken. System activities are here observable. Normal and intrusive activities have distinct evidence. Intrusion detection approaches. There are some approaches like features which evidence is extracted from audit data. Analysis approach that is piecing the evidences together, that is misuse detection, signature based, and anomaly detection which is statistical based, and deployment which is network based or host based. Development and maintenance, hand coding of expert knowledge, learning based on audit data. Misuse detection, here is the pattern matching and intrusion patterns like pattern matching, intrusion activities which is can be carried out in number of activities. Here we have the example and we can't detect new attacks. So anomaly detection, which has been again and again repeatable, which is there are some measurable target with the graph and the probable intrusions are given here. So the normal profile and abnormal profile is given. So what will be the CPU process and the process size which is being taken. Next is, if any problem, then relatively high false positive rate. Anomalies can just be new normal at C, the monitoring networks and host. Here we have the network packets which we has been dumped with TCP, and operating system events we have like BSM. So here we have some key performance metrics. It is algorithm, that is alarm A, intrusion 1, detection, that is true alarm, which is being P of A of I. False negative rate we have and the true negative rate we have. So the architecture is scalable or resilient to attacks. Host based IDS, using OS auditing mechanism. BSM and Solaris logs all direct or indirect events generated by a user. Strays for system calls made by a program. Monitoring user activities, that is analyze shell commands and monitoring execution of system programs. Analyze system calls made by send mail. Network IDS, deploying sensors at strategic location. Packet sniffing via TCP dump at routers. Inspecting the network traffic. Watch for violations of protocols and unusual connections patterns. Monitoring user activities. Look into the data portions of the packets for malicious command sequences. May be easily defeated by encryption. Data portions and some header informations can be encrypted. Other problems we have. An architecture of network IDS. We have here policy script, event control and TCP dump filters like policy script interpreter, event engine and libcap and network. Firewall versus network IDS. Firewall, which is active filtering, fail close. Network IDS, which is passive monitoring and fail open. Requirements of network IDS: high speed large volume monitoring, real time notification, mechanism separate from policy, and extensible, broad detection coverage, economy in resource usage, resilience to stress, resilience to attacks upon the IDS itself. Case study for SNOT IDS. Problems with the current IDS is knowledge and signature based. We have the largest knowledge or signature based, ineffective against new attacks, individual attacks based, which is like intrusion A detected or intrusion B detected. So no long term proactive detections or predictions can be taken. Statistical accuracy based, it is X% detection rate and Y% false alarm rate are the most damaging intrusion detected. Statistically configured. Adaptive, next generation ideas like adaptive or scenario based or cost sensitive. Adaptive, which is detect new instructions. Scenario based, which will be like to correlate the multiple source of audit data and attack information. Cost sensitive, like model cost factors related to intrusion detection. Dynamically configure IDS components for best protection or cost performance. Adaptive IDS modeling engine. We have anomaly data, we have misuse detections. So we have anomaly data as ID models, which is misuse detections, and we have modeling engine. So it is called as adaptive. And anomaly detection, semi-automatic can be used. So like semi-automatic can be like the models which will be given, and like how the raw audit data can be split up into packets, and again it can be divided into connection or session records, and then again it becomes a model finally. So here are the, thank you.